In this video, we're going to talk about vertical asymptotes. Okay, basically a vertical asymptote is an imaginary line used to aid in graphing a rational function. Now, this line is where the rational function is undefined by its input x. So you're putting in a value that will not work. Okay, so this is basically the part of the domain that does not work in the rational function. So the rational function infinitely approaches this vertical asymptote but never crosses it. So I have three functions, f of 1, f2, f of 3. Okay, these are my three different functions, and we'll look at their graphs and kind of look at where their vertical asymptotes are. Now look at this function. What is its domain? Alright, meaning I could put every number inside here for x and evaluate it here and here and get a number out. But there's only one number I can't put in there, right? Because look at the bottom. You can't have division by 0, right? So if I take function f1 and I put 3 into it, this is what happens. 2 times 3 minus 1 over 3 minus 3. This becomes 6 minus 1, or 5, over 0. And that is undefined. So 3 is not in the domain. The domain of this function is all numbers from negative infinity up to 3 unioned with 3 to infinity. Okay, that's the domain of this function, and what we'll see when we graph it is we're going to see that this graph does not cross x equals 3 on the graph. And what we'll do is we'll put a vertical line at x equals 3, and that will be our vertical asymptote. Here is the graph 2x minus 1 over x minus 3. Here is a t-table, inputs from negative 10 up to positive 2, and I can keep going, and these are the outputs. Now look as we go from negative 10, which is over here, and we approach 3. So negative 10, negative 9, negative 6, etc., etc. These numbers here are 1.6. They're getting closer and closer to 1, and then they get closer and closer to, look at this, they're getting smaller and smaller, right? They're going this way, going down, getting smaller and smaller, and then at 3, it's undefined. At 3, it's undefined. That's because you can't put 3 in here. Okay, well what happens as we get 2, it's negative 3, what happens between there? Well, it gets closer and closer to this value here. They get smaller and smaller, so it gets negative 4, negative 5, negative 6, really, really small. Let me just change the table step and show you what's happening. So as x is 2, it's negative 3, and then we jump right to 3. So I'll change the table step. We'll start at, let's say, 2, and then let's go up by, say, I don't know, 0.1, so 1/10. Alright, so I'm starting at 2, I'm going up by a tenth now. So I'm right here at 2, I'm going up by tenths. Notice as I go up by tenths, what's happening here, right? This number right here is getting super, super small. Look at that, 2.9, it's minus 48. And then as soon as I get to 3, it's undefined. Then after 3, it's 52, 27, 18, because it's up over here. It starts really high, and it comes back down this way. So we can't actually get 3 into the function, but we can get quite close to 3. And on the left side, it goes way down to negative infinity, and on the right side here, as we go this way, it goes up to positive infinity. Alright, but we can't put 3 equals there. These are the outputs, remember. Alright, so now you'll see that they have this dotted line here. It's a vertical asymptote at x equals 3. Now this is a horizontal asymptote. We'll talk about that in the next video. But vertical asymptote at the undefined value. Okay, if we go back to our next function, f2, x plus 3 over x squared minus 1. Well, we want to find out where this function is undefined. So in the denominator, we're going to actually have to factor. This is a difference of squares. So it factors into these two. I can see that x equals 1 and x equals negative 1 are the values which will make the denominator 0. So these are my vertical asymptotes. So I'll just say VA is x equals 1 and x equals negative 1. Let's graph the function f2. Here's the graph of the function f2. You'll notice that there are two asymptotes. One right here at x equals 1 and one right here at x equals negative 1. and then you'll see the graph. There's three parts to this graph because I have to the right of the vertical asymptote, in between the two vertical asymptotes, and on the left. Remember, here's the table again, and you'll see that there are two undefineds because you can't put x equals 1 in there and you can't put x equals a negative 1 in there. And these are the outputs of all the other x values on the right, in the middle, and on the left. All right, our third one, F3. Again, the denominator needs to be factored. So I factor the denominator. X, what two numbers multiply to negative 6 but add up to negative 1? Negative 3, and positive 2. So my two vertical asymptotes are 3 and negative 2. My vertical asymptotes. All right, let's graph this one. Here's F3. Vertical asymptote at 3, vertical asymptote at negative 2. Graph to the left, graph in between, and graph to the right. The tables again, look at 3, undefined, and negative 2. I guess I got to go up here. Negative 2. Undefined as well. So basically, what you're doing is just graphing in those vertical asymptotes where the function is undefined. This will be the guide to help graph. All right, let's have you try it too. Here is the first one, F4, and here's the second one, F5. Pause the video and then see if you can find the vertical asymptotes of this one and this one. And maybe just sketch them on a graph, just the dotted lines. That's all you have to do, just sketch the dotted lines, and I'll show you this in a moment. So pause the video now. Okay, here's going to be the solutions. F4, what we need to do is factor the denominator. X minus 2, x plus 2. So therefore, the asymptotes are at x equals 2 and x equals negative 2. So just the denominator, right? All right, check the graph. Here they are. At x equals 2, x equals negative 2. Notice x equals 2, it's undefined. Move up. X equals negative 2, it's undefined, and x equals 2, it's undefined. Those are the two values it's undefined for. All the other values will give you part of the graph. If we go back to the second one, F5, basic, there's only one, right? X equals negative 3. All right, look at the graph. What you should have graphed? You should have graphed a vertical asymptote at x equals negative 3, right there. Now you'll see that there's the graph to the right of it and the graph to the left of it. And at negative 3, if we go up here, you'll see that it is undefined at x equals negative 3. In conclusion, vertical asymptotes come from the denominator. Where is the function undefined?